In this lecture, we will learn how to calculate a weighted mean. This image is a Wordle made from our course syllabus. I pasted the text from our syllabus in the web application at wordle.net, and it made the more frequently occurring words have greater prominence in the image. A weighted average works much in the same way, but with numbers instead of words. The weighted mean is used when two sample means have different ends. The formula for calculating a weighted mean looks pretty intimidating, but once you break it down into the symbol's meanings, it isn't too bad. To calculate a weighted mean, you simply take the size of each sample and multiply it by that sample's mean. Add those products together and then divide by the total of all the ends added together. The example from the text is for calculating a person's GPA. If you have different numbers of credit hours each semester, you have to ensure the semesters with more credits receive greater weight than semesters with fewer credit hours. This table contrasts the two methods for calculating the GPA. In the flawed method, each semester is treated equally. In contrast, the correct method ensures the semesters with 19 credit hours receive greater representation in the overall weighted mean than semesters with 16 hours. Notice how the overall averages are different. Let's practice calculating a weighted mean. In this example, there are two groups. Group A has an N of 5. Group B has an N of 3. I would expect an average, well, definitely between 3 and 15, and I would anticipate the weighted average to be closer to the low end. I'm guessing around 7 to 8. Find the average group A score by adding the values and dividing by N. 3 plus 5 plus 5 plus 7 plus 9 equals 29. 29 divided by 5 equals 5.8. Therefore, the average of group A is 5.8. Next, we're going to find the average group B score. 11 plus 11 plus 15 equals 37. 37 divided by 3 equals 12.33333, repeating. So now I know that my weighted average must be between 5.8 and 12.3. It's another property. So I expect, again, an answer somewhere around 7 to 8 because of group A's larger N. The weighted average is calculated by taking 5.8 times 5 and adding 12.3333 times 3. Hit enter and you get 66. Since the N for group A is 5 and the N for group B is 3, the total N, therefore, is 8. So to find the weighted average, take that 66, divide it by 8, and you get 8.25, which matches our prediction. Because I know the individual scores in this case, I can actually just calculate the mean the old-fashioned way, too. If you pool all the values together, 3 plus 5 plus 5 plus 7 plus 9 plus 11 plus 11 plus 15, you'll get 66. No big surprise there. N is 8, and of course, same math. 66 divided by 8 is 8 1/4. Therefore, I definitely did my weighted average calculation correctly. Well, why do we even need a weighted average then? Well, sometimes you don't have the individual scores. What if you wanted to calculate the weighted mean for a scenario in which you know the size of each group's N and the overall averages for each group? In this example, I can estimate the weighted average as definitely being between 37 and 48,000. And I would anticipate the weighted mean to be closer to 48,000 because there are more men than women in the sample. So an estimate around 45 grams seems reasonable. The calculation for the weighted average is 30 times 37,000 plus 70 times 48,000. Adding those together, you get 4470000. My total n is 30 plus 70, or 100. So therefore, my weighted mean is 44700. This value matches my estimate again, so I am confident that my answer makes sense.